So my name is Etienne. I'm a developer for Shopify. I'm also a Google Dev expert. I've been introduced anyway. There's like all these things I do. I'm basically very privileged to have the chance to speak to people and be invited back to conferences. And I'm really happy to see you all here today. And that's how I feel about that kind of stuff. So thank you, Shopify, for sponsoring me to be here today. And thank you for DevFest Florida for inviting me. And thank you for everybody else that always helps with these things. All right. So we're here to talk about a simple approach to MVI architecture. So this is a pattern I've discovered personally a few years ago by reading Hans Dorfman's blog. So the general structure and idea behind MVI is this sort of data flow that you see here on the slide. So this idea that you have a view that emits UI events, so people click on different things. These are turned into intents, which are like these sort of concepts, objects that know how to modify a model and do some piece of work. And that piece of work is applied onto a model. And once that happens, the loop back is that the view itself subscribes to that model to be made aware of when different things change and update itself. It's a unidirectional data flow. All right, so what's so special about this pattern? What's its superpower? Why is it compelling over regular MVVM? So those are important questions, and I don't necessarily expect folks to see my talk and be like, I need to re-architect my app right now when they leave, right? A lot of the high-level concepts we're going to be talking about here today, they carry over really nicely to other architectural patterns. At my own company, we are more into MVVM, and a lot of these patterns apply to Google's MVVM flavor, different flavors. Like if you worked with live data, they are themselves pretty much a reactive API. So a lot of the stuff we're going to learn today, a lot of these ideas are reapplicable somewhere else. So if I personally had to describe MVI's superpowers, I would say that it's functional, immutable, and reactive. Those are the three big ones. So those are three very big words. What do they exactly mean? So the way I look at it, functional programming is the power of pure logic at work, right? It turbocharges code reuse. It's really interesting for that. If you write a function, typically a function doesn't carry state. It gets a parameter in. It returns some sort of piece of calculation to you, and that encourages code reuse. Immutability is a nice bonus that comes along with functional programming. When you have immutable objects that are being passed around, then thread safety is a lot easier to handle. So that makes a lot of things a lot safer. Reactive programming, well, basically allows you to be everywhere at once, is how I look at it. It allows you to safely parallelize work. And if your framework is RxJava, you're going to get a very powerful API that allows you to manipulate streams of events. So you can be everywhere at once, but still focus in your development day-to-day on one task at a time. So all these superpowers sound really cool, right? The problem is if you're not super careful about them, you can mess yourself up. The learning curve can be really difficult, and sometimes people get a bit ambitious when they get access to RxJava. They're like, this can do everything. I should do everything with it. And then things start going a bit bad. So I think I named this talk Simple MVI Architecture for Android. So it's fair to say that if you ask a lot of programmers and you ask them to describe reactive programming, functional programming, simple is not what comes to mind. I still call this talk Simple MVI Architecture because the MVI approach, from my point of view, simplifies app building in a bit of a counterintuitive way. So it does that by forcing you to handle certain things up front. So you need to handle certain things like safe asynchronous work, canceling in-flight requests before starting a new one, handling server errors and all of that. These are, or even just spammy events from the users, right? These are things that we typically don't think about. And a lot of that stuff dovetails into the Android ecosystem as well. If you think about configuration changes and all of these things, a lot of us, when we first start out, we sort of write an app, we don't think about all these things, and it bites us in the butt a bit later when we finally rotate our screen and the app crashes or something. Or that there was a request in flight while you rotate that screen. What happens then? These are things that you don't necessarily need to think about, and they surprise you later, whereas with this kind of architecture, you're sort of forced to face these problems up front. All right, so Let's try to explain a bit more in detail what these big words mean, reactive, functional, all of that, in the context of MVI. So this is the simplified graph we saw a little bit earlier at the beginning. So reactive programming in the context of mobile looks a little bit something like this. It's concerned with data streams and how to propagate these data streams around. So if you think of your app as a reactive system, very simplified way of looking at it, the app renders to the device screen. Your user sees that screen, interprets something. Oh, there's a button. I need to click on it to submit a form, right? And then the user clicks on the screen. That becomes a touch event of some kind, which goes back into the app. The app handles it, updates its screen, and so on and so forth. And the loop continues. That's fairly straightforward. Now, if you translate that to the MVI division of labor, you can think of a view as a placeholder for the user almost, right? Events coming in from the view are really triggered by the user. And then these are translated in something called intents, right? We've touched on. So intents then processed by the model, and these model updates are propagated back to the view. The user sees them, so on and so forth, right? That's how that fits into our world. So MVI, as I said, draws a lot also on the ideas of functional programming. So in functional programming, you treat computation as an evaluation, like if it was a mathematical function, basically. So that's how you avoid state changes. You're not supposed to mutate data if you're really doing functional programming and looking at things like functions, right? If you call a function that adds two things together, in the mathematical world, you're not expecting one of the operands to suddenly change values, right? You're expecting two things in and one new thing out. These are separate objects, so to speak, right? Right, so how does this stuff apply to our architecture? Well, if we go through the idea, we're basically turning each of these little boxes into a function, getting something in and pushing something out. So they each feed into one another. And to better understand how this actually works, we're going to take a look at what type of output each of these blocks will generate, right? So the view generates view events. Those are pretty straightforward. So if somebody clicks on something, that's a view event. If somebody edits a text field, there's a text change, that's a view event. The next layer is what will map each of these view events into something that makes sense to the model. So we call these intents, again. So if you imagine, for example, that user pulls to refresh on the screen. So a pull to refresh event is going to be emitted from the view, and that's going to be transformed into an intent that would be something called the refresh list intent. So in the context of a to-do app, as we'll see, that's what we're talking about today. That's what it would basically look like. You'd pull to refresh, the event would go in, and that'd be that. Right. So when the model processes an intent, like refresh here, it's going to do a call to the network. We're going to get a new list, and then that model will get updated. So if you think about it, though, if you're doing a pull to refresh, there's going to be a pause in the middle. The model at some point is going to have to say, hey, I'm refreshing right now. Right? There's this state where I have an old list, I am myself refreshing, and when I get a new list, I'll be back to my regular state with a list available for the users. All right. So I'm using the word state a lot here, which might seem like a contradiction. The thing to remember about this state is that it is not mutable state, it is immutable state. So when we're passing this information along, we have different instances of it, but it is not something that can change under the user's feet, right? That's a key thing to remember throughout the whole talk. All right, so now we're going to dig into basically the meat of the presentation, quite honestly, like the model. How does that work? How do you manage state in that specific way? So I mentioned we're using Google's To-Do app as the core example. To-Do apps themselves are fairly straightforward, so I'm going to go through quickly how to build that model, but each of the pieces are kind of important. So you have a list of to-dos, right? So that's the first thing. When you add things to the list, you're going to have, you're going to have a few new items, and you're going to be able to check them off and all of that. So the first thing we'll want is a list of tasks. That's not a big surprise right there. So what would we want in a task? So we're going to have here, we're going to add specific things. We're going to have an ID. Usually those are useful. Last update is good if you're going to synchronize with a server. It's going to allow you to know how fresh that information is. title and description, that's sort of a weird little thing with the to-do app that Google has, which is useful for example purposes. It has not only a title of the to-do itself, like you'd see here, but it also has a little block of description that can be edited on a second screen. So that's part of our model. And obviously, we have a completed state. Is it checked off or not, that task? Right? So that's the basic of it. Beyond the list of tasks, our model, our list of our app itself is going to have another concept that I touched on a few seconds ago, which is a sync state. So this idea that right now I might be synchronizing with the server, right? And we sort of need a way to communicate that to the rest of the app. So again, we're thinking in sort of business logic terms, right? We're thinking about this model that might be synchronizing right now. And so that's one thing. And if you think about it, then you can sort of dig into what kind of state transition is going to go. It's really old school UML, right? I kind of find interesting that it's kind of part of this idea that you want to cover all your bases. We're thinking about all the problems up front. Basically, the idea is that your model is typically idle, so that's when stuff is in memory and you can edit it. And then whenever something on the network is happening, you want to be able to sort of take note of it and react to that in some places in your app. So this little state diagram shows you this idea that from idle you can refresh, for example, the list, or you could be checking off a task or unchecking a task. That would trigger some piece of work that I call process here. And that might succeed. Then you'd go back to idle, and then the data in the model is going to be updated alongside that state that goes back to idle. But it could also fail. So then you need to cover that state with an error state, in which you'd probably put like details of what the hell went wrong and things like that. OK, so last detail, the app has a filter button. That's not that interesting, but that's part of the model, so we put it in there. And we've defined the whole model state for the app, basically, right now. So this is what it looks like in code. Data classes in Kotlin. Who here is basically writing Kotlin day to day, just for checking purposes? About a third of people here. So you might not be familiar with data classes. They have a lot of nice features. One of the things is that they are basically immutable to start with. So this one here, we're using val, which is, they're all read-only. So when you create a task model state here, what's in there is not something that somebody can mutate on you. Even the list of tasks is a non-mutable list. So all of these things are basically frozen in time. We'll see other features of the data classes in Kotlin that are kind of interesting for that stuff in a minute. So, right. So if you need to bring your state to life, then you start looking at the MVI flow diagram again. We see that a model holds state, right? And it's also supposed to process intents to change that state. So we need to sort of look at how that would work. How could we do this? So if we think about the model itself, that's right here, right? And then we want to store that model somewhere, that data, and we want it to be able to change it and also observe it. So this is basically the model's interface. So it has basically like a math function, like I was saying earlier, two things. It has a producer, so that's basically the outputs. That's an observable. So question, raising hands, don't be shy if you've never done it before. RxJava, who's worked with RxJava here? Okay, so a good bunch of people. So observables are not necessarily a new thing. If they are new to you, they're basically fancy listeners. So when you have an observable and you subscribe to it, you're going to get called repeatedly for each new thing that comes down that observable. So here, the model state is how the views are going to subscribe to the model and get updates and refresh themselves. The consumer here, the input, the process function, is the one where you're going to tell the model, hey, I have this intent to change stuff or do some work, so please run it on the model and update yourself. If we go, that's the, forgot about that slide. Trying to make it really clear, input, output, right? This is what's going on. One thing to note is I'm keeping the types generic here, and you'll see why in a second. Right, so what is an intent? So the key to all this state modification is to remember that intent is a function that takes a type in entry and gives you a new type out. What this really means is that an intent takes the old state of the model and gives you a new one, a new modified one. And here, data classes come in really, really handy. They give you this copy operator. So here I'm creating an intent, to update a task. So it's not the list of tasks and everything else, but if I want to edit the title of a task, then the intent would basically be taking in it as the it parameter in Kotlin, the old task. It copies everything that was in the old task, only changes the title of it to a new task title. And what comes out of this intent is a new piece of state. The old task with the title modified, and we hand that back off to the system. So this is seemingly simple, but that's the core of the pattern. This idea that you take an old thing and you generate a new one, and it's immutable, and you're not mutating it, et cetera, et cetera. All right, so when that runs, this intent is going to be basically passed into the model, and that model will somehow, we'll see how in a second, run it over the current stored state and come up with a new one, store that, and tell the world, hey, we have a new state here. All right. So how do we process that intent? That's where things get a bit more complicated, but that's the heart of the whole MVI pattern. Like, honestly, today, we might run out of time for a few of the slides, but this part here is the key part for the whole pattern. It's something that you also will see used in React. Flux, I believe, is the name of the library that is a model store, in React. So it basically plays the same role. If you're aware of the Flux library, I believe, if I understand properly, it's implemented something like 50 lines of code. And this is effectively the same thing with RxJava and Kotlin. So all of this, I'll have a link at the end of the presentation where you can basically get all that code if this looks too complex for now. But this is basically your model store and what will update those changes, and we'll take a look at how that actually works. So if we start with the input side, when things come into the model, so we get that process function that's going to get called. It takes the intents that it's getting and basically drops them into the intents publish relay. So what is a publish relay? Publish relay is basically a publish subject. So for those of you that have done RxJava, there's a good chance you're familiar with it. It's a library. Relays specifically are a library by Jake Wharton that allow you to sort of take out a few things from subjects that are kind of problematic. Subjects are long-lived items, objects that are going to give you stuff like errors if there's a problem, and they can be terminated. And that doesn't really fit well with the idea behind subjects anyway. So the relay library takes all these concepts out, and it just becomes a piece of pipe that you can drop things in and somebody else can listen in on. And you don't get all the baggage of the error handling that you actually don't need or don't want in those situations. So what a subject, publish subject specifically does here is that when you subscribe to it, it's going to give you everything else that comes in as it comes in. It's not going to tell you about the past history of the thing. It's only going to be future objects and future sort of incoming events that are going to be processed through it. So, right, again, a little piece here about Rx relay, where it comes from. So the next step is to take this relay and sort of get the intents that are coming down that pipe, and we will handle them on the Android main thread. So that's what turns our intents pipeline into basically a message queue. So that ensures that we keep, that we safely handle all the work, right? Like you're handling it from the main thread, things are good. The state won't change from two different threads, and you won't end up with a race condition. It's not because we're immutable that we stop thinking about race conditions, right? Then the scan operator is where the magic happens, and it's probably the part of the presentation most people will sort of get a bit dizzy if they haven't done RxJava before. Stay with me. So if you've heard me say so far, there's an old state, we apply an intent to it, and we get a new state, this might speak to you. The part that's a little bit complicated is that you give the scan a starting state. And that scan will take the new state you give it, store it, and keep it handy for the next intent that comes along to give it this now old state so it can generate its new state. So, no fear though, I have the perfect diagram to explain how this works. Right, there's a note here, pause for laughter. It's terrible, right? And it's why marble diagrams have this terrible reputation. But if you, bear with me for a second, if you look at the star, think of that star as your starting state, right? It's when your task list is empty, you're not doing too much with it. And then each of these colored marbles, sorry, like the red one at first here, is an intent. So this is the red one is your first intent that's going to be applied to your starting state, and you get something that's a combination of both, if you will, out of it. Of course, again, this is a new copy, a new object, and a new immutable object, so it's not like you've just mutated the thing, although you could, but you shouldn't, right? So basically, this is the idea shown of this is how you chain all the events and how these intents are processed. So scary diagram, but really, really cool operator. So to finish up this model store, we need two more things. So we need to be able to share the stored value. And this is what replay does. If you're familiar with RxJava, this might speak to you. If you're not, then don't worry. Just trust me, it works, and go read up on it later. Again, there's a little marble diagram with it. Yay. The only difference you might want to note is that once this observable is active, right? Anybody else that comes in, say at the bottom here, when we're subscribing at the very last, we're going to get the current state of the store emitted first. So it works a little bit like live data. So when you subscribe to it, you get the current state. So if you're interested in knowing what's the task list state right now, when you subscribe to the store, it's going to be here. Here's the list of tasks that we have right now. And oh, by the way, we'll give you all the updates that are coming up next. So that's from the consumer's point of view. That's from the view's point of view. That's what interests you. Then that's the replay operator gives you that. It makes your observable shareable, and it also makes it somewhat persistent, which means if nobody's listening to that store, it's still processing events, it's still storing the results, and it's still active there. That's an important part. All right, so how do we actually use this thing? If we're trying to operate on the tasks model store, you extend that store, you pass it a type, and you give it a starting state. So from the user's point of view, from the API user's point of view, these model stores are really simple to use. And they're really, really practical. All right, that's it for the model. So we're sort of actually doing OK on time, surprisingly. I didn't believe we would. All right, so getting the model right, again, I've sort of said this at the beginning, is really key in this pattern. If there's anything you should take away from this talk, I really believe that this is the important part. And if it's the part that puzzles you, please take down the note of the GitHub URL I'll give you at the end and look at it if you're curious and want to use it. There's a lot of reusable code in there. I'm pretty sure you'll like it if you get to play around with it a little bit. All right, so we're going to focus a little bit now on actually hooking this stuff up to an Android app. So if we focus on the view and intent side of things, a few questions will come to mind. Like, how do we take these, how do we actually build these view events I've been talking about first? And then how do we turn them into intents? And the third question we're going to answer with this little block of the presentation is, how do we hook all that up to that model store I just showed you? So in the sample code, I've been using this view contract interface as sort of a way to mostly say a view has to do the following things. It also serves a bit of a side, it serves for a second purpose, basically, because views in the MVI model very often are going to be things like fragments and activities, which is sometimes controversial for folks, right? Activities and fragments are basically controllers, if you will. But in a lot of the architectural patterns you see out there, they are sort of seen as views now. And still not quite right, is it? Because they do a lot of lifecycle management. So in our case, what I've tried to do is to create this interface view contract so you could decide to make your fragment implemented, just as well as you could decide to actually create a view component of your own and have that one implemented, and then hook all that up when your fragment comes alive. But it also makes it a little bit easier to reason about the whole pattern. So that view contract, first thing, is going to emit events, right? And we're going to state that these events are going to be themselves an observable. You're going to get these events through an observable that the view is providing. So how do we build that observable to make it a bit more concrete? So if we take the task editor fragment from the Google app as an example, right here, it would output edit task view events, this generic concept of these are all the events coming from the edit view. And when we output these, we want to first output them and then turn them into intents. So if you edit the title, let's say, right, you're going to click on the title, and then we're going to need some sort of event to send down towards the model. So in this case, we're going to call it title change. It's a data class again, and it has a payload, which is a title. So it's going to send the title down the pipe so that the model can eventually process it. If we click on the description, same kind of story. We're going to have a description change. And if we click on the save button right here, we're going to want some sort of save task event click thing being sent down. So all of these are regrouped under the banner of the edit task view event. So that's kind of really practical. And as you can sort of see, our observable is going to send these types of events down the pipe. So we're going to have one type to deal with. And sealed classes, as we'll see, have really nice properties that allow us to sort of map them into different things. There's one thing you should know about right now is that the easy way to get events out of an actual Android view is through the library Rx bindings. Again, Jake Wharton library, really practical. So how do you use that? You use it this way. So if you have an add task title, which in this case is a text label, an editable text label, then you're going to get this nice extension function called text changes from the Rx bindings library. What this gives you is literally an observable of text changes. So all the observables you could be wanting out of your UI, Rx binding provides them out of the box. And they're all through extension functions. So that's really easy to use. What we do here, ideally, is to map these raw UI events into our own typed events that I just showed you, right? So in this case, if somebody clicks on the title, edits it rather, then you want a title change event to be propagated down the pipe. Same thing for description, same idea, right? So you're going to want to subscribe all your different UI components and turn them into observables. That's going to give you a lot of observables. Well, no fear, because we've sort of mapped them to one type. So what we can do then is to merge all of these together. So RxJava gives you observable merge, so that allows you to take a lot of different observables as long as they're of the same type, which thankfully enough, we've created a common type for them through the sealed class stuff. So that's going to be one type of all the events that your view can generate. All right, so that's a lot of stuff happening. Time is running down. It's a bit quick, I know. You can always come and find me after the talk and ask me a ton of questions, and I'm happy to share notes, by the way, right? Okay, so we've learned how to emit events from the view, and we're going to quickly see how to turn those events into intents. How do you hook them up to a model? So again, it's the first time here in the presentation that I use the power of Kotlin extension functions. So if you're familiar with extension functions, they're really practical to add behavior to existing stuff. You might not have been using them in RxJava this really specific way. That's a really powerful way of doing things with RxJava. So what we're saying here is that our observable of task view event, we're going to create a function that turns all of these events, well, actually, that turns that observable itself into an observable of intents. So that's going to sort of create our mapping one-to-one. And then here is kind of the power of functional programming, too. Because what's interesting here is that this function is probably going to be a top-level function. It has no state of its own. Right? It works off of something else. So what you're creating here is a piece of code that works for any observable of task view events anywhere in the system. It's not linked to an actual instance of a thing. It just is pure code, reusable, really nice. So the general idea is that you're going to be taking these view events, and for each type of view events you have in a when clause, you get that through that sealed class stuff that I was sort of mentioning a few seconds ago. So you're going to be able to decide what type of intent you want to have out of each of these events. Now, this is what the code looks like when you start. Well, I've cheated a little bit here. I've added an extra extension function at the top here that allows me to create these intents really easily. So this is just basically a little piece of DSL. Like, don't be scared. DSLs are not that hard. What this little piece of DSL gives you is a really nice way to define a new task reducer, intent, sorry. So we can then map our title change to an edit task And all we need to say is, OK, edit task, that intent only really copies, modifies the title, creates a new copy of our state, modifying the title, and that's it. Or changing the title is what I should be saying. All right. So that's how the conversion happens. And once you have that conversion, to tie everything off so that you can start sending view events right up to your model, in your fragment, on resume, what you're going to be doing is subscribing, ultimately, your model to a stream of intent that is built off of events, right? That's really powerful stuff in one line. But once you've done all the work I've shown you, this is how you would express it in your fragment. So really very little code to maintain here. If you're not familiar with RxJava, you might see I'm using this thing called disposables, and I'm calling clear on it. So the thing to remember about RxJava and observables is that when you run a subscription, it's active, and as part of the Android lifecycle, you want to shut those things down. They don't really make sense once you hit on pause, right? Since there are events coming from the view, there are events from your button clicks and all of that, when you hit on pause, theoretically, you might not be coming back, right? So you don't want to have these things sticking around. You want to cancel the subscriptions, and they're not that expensive to restart on resume anyway, so there's no big deal here. It's basically the same kind of thing you're doing with listeners if you think about it very often. All right. So very quickly ran through. We're at 30 minutes now. I'm going to go over. I'm sorry. But we're almost there. So the last part we need to cover is to basically see how do we turn model changes, rather, how do we subscribe our view to model changes? If the model changes, how do we make sure that we update the view? And when a view starts up, maybe more to the point, how do we just get one copy of whatever's in the model to initialize ourselves? So again, a bit more code, but not too much. So the other half of all of this is that we've just seen how to subscribe the model to the view, basically, to get the intents. And now what we're looking at is how to subscribe the view to the model. So the editor store, which is where our model is stored, has this model state observable that we subscribe to. Now the subscribe view, it's just a utility function to sort of regroup all the view subscriptions in one place. That's just basically housekeeping. You could be doing all of these things in your on resume and on pause blocks, but it gets messy. So that's just like a good convention I recommend people use. If you look at the sample code, there's a lot of these little bits of convention that help sort of manage this pattern so it doesn't become like a big old mess in your code base. The basic idea here is that we take our observable of task editor state, so that's our model. We create another extension function on it that will subscribe to it. And underneath, if you ignore the composite disposable bit, if you're not into RxJava, this won't speak to you. If you're into RxJava, that's just how you manage all the subscriptions in one blob, right? You can dispose all of that in one shot afterwards. Anyway, so your consumers, here what we're doing is that we're filtering, well, actually that little bit of code, I copy-pasted a bit of code that's a bit more complicated than it should be. Ignore the of type first. You can come to me and talk about this after the talk if you're curious. There's concept of state management that are in the repo for the GitHub repo that are not covered in this talk that are there. But the really important bit is that the first element function that you see for both of these subscriptions. The idea is that here we're on a view, the edit view that has editable text fields. So when you start up the fragment, you only want to initialize it once. So what this says is basically take the model store, get the current state of it, the first element, just get what's in there now, and map that to my title, and then let's subscribe my add task title and my add task description text fields to that. So what's that text function after each of these UI elements? That's another piece of Rx binding that provides you with consumers, they're called in RxJava parlance. What that means is that they give you an easy target so that if you want to subscribe your UI to an observable, this is what you use. By using the text function, you get back basically something that is subscribable, an observer, right? So you can pass that into the subscribe function of any RxJava stream, and it's going to get updated every time something changes. Or if you use the first element function like I am here, that says, don't make it that an observable, make that a single, basically. Like make that a subscription that only returns one result, and then we're done. Because we're an edit field, right? You don't want to create loops, right? If you're editing something and then the model changes and it tells your edit field, hey, this value changed, that won't work, right? But if we're talking about text labels, you're going to want to subscribe to the full stream. Anyway, a lot of RxJava mumbo jumbo here, but those are basically it. And that's, yeah, a little slide there for highlighting how first element works. And that's all the time I had. I skipped a few bits. Did you notice? So at least my deck is pretty much on cue. So we've basically very quickly covered how you can subscribe to a model and update your view. And that's it for me. Perhaps the most important slide of this talk, the GitHub repo. I love talking about this stuff. As you might notice, I'm all enthusiastic. And please come and see me after this talk and let's chat. Thank you very much for your time. I hope you enjoy the rest of the conference.